Hey guys, we're going to start talking about electron affinity. So in this video, we're going to define electron affinity and look at its trend. We're going to look at the relation between electron affinity and ionization energy, and we're going to look at the irregularities within electron affinity for the elements on the periodic table. So electron affinity is what it sounds like. It's the affinity of an atom for an electron. It is actually defined as the energy change that accompanies the addition of an electron to a gaseous atom or ion. Okay? The first time we add an electron to an atom, it's always going to be, or most always going to be exothermic. So most times the electron affinity for an atom will be exothermic. So it will release energy, so it will be an energetically favorable thing. With our trend of electron affinity, there's not a real significant trend with electron affinity. For instance, there's no real big change within a group. Mostly a somewhat downward trend, but not exactly. For the most part, there's not much of a trend as we go through our periodic table. So the electron affinity itself is going to increase as you go across a group, generally. But there are irregularities there. For instance, here and here, we see that we either have very low values, or if we see stuff like this means we have a positive value. And here as well, we have positive values. And you're going to get positive values in electron affinity, which means it's not favorable, or it is less favorable, like we see here, when you are trying to add an electron to a full-filled or half-filled state. So irregularities in the trend exist when trying to add an electron to a full-filled or half-filled subshell. So that's what we see in group 2, group 15, group 18. In each one of these cases, we're trying to add electrons to these two are full-filled states. This one is a half-filled. And it just does not like it. So because you're trying to add that extra electron when it's in a energy minimum, you're going to have a higher than expected electron affinity. And it's similar to what we see with our trend in ionization energy. So ionization energy and electron affinity are very, very similar, right? One's removing electrons, one's adding electrons, but it's still that whole idea of what's going on with electrons, how it's going to affect our electron diagram, where electrons are at. In ionization energy, we got to like little energy minimums when we were removing electrons that allowed us to get to a half-filled or full-filled state, which again is more energetically favorable. Okay, that's everything I've got for electron affinity. I will talk to you guys later. Bye.